stoichiometry problems. Problem number 2. Oh, it's gonna be quite a little bit difficult compared to the other one previously, right? Okay, the question states like this. Propane reacts with oxygen gas to produce carbon dioxide and water. What volume of carbon dioxide will be produced if 8.4 liters of oxygen gas reacts with excess propane gas excess? Oh my gosh, propane! How can we... This is word statement, not chemical formula given. So propane, you need to identify first. This is the first issue. You need to determine the chemical formula. Carbon dioxide, the ratio is very easy, right? CO2. Okay, now this involves very obvious combustion process. Okay, it's gonna be complete combustion. Okay, so there will be rapid oxidation with propane and oxygen gas. Okay, okay, like that. So propane. So based on the memorization na lang, because it's very very tasky to explain the organic, principle for this. So let's assume we know that already, the chemical formula of propane. Okay, so C3H8. Okay, that's propane. Okay, mga palangga. Okay, now oxygen gas is O2. Okay, carbon dioxide is CO2. Okay, and water. Very easy. Water. H2O, this one. This is our data, right? Now, regarding the quantifiable data or measurable data, we have only one with 8.4 liters of oxygen. So we have 8.4 liters of oxygen gas reacts with excess propane. Okay? So reacts with excess propane, meaning propane plus oxygen gas. In this kind of equation, in this kind of question, guys, there's a lot of elements and compound involved. So what comes first in your mind? There's a chemical reaction involved. It's not purely data, solo data, or whatever, or solo element. So in this case, you need to understand that there's a chemical reaction because it states that oxygen reacts with propane. Okay? So you need to show the chemical reaction, and then after that, you have to balance before proceeding to the solution proper. So again, in this case, there's no standard formula to be used. Okay? It doesn't qualify to other ideal gas formula standards. We have a lot, right? For example, Avogadro law, Pascal's law, okay, like that. Boyle's law, Charles' law, Gay-Lussac's law, ideal gas laws, something like Van der Waals laws, something like that. So we can qualify that there, okay? Because the main reason also there's only one given equivalent for solo flight. How can you do that? In the standard formulas, at least there must be two data. But here is only one. Okay, you will force yourself again to use the dimensional analysis conversion way of solving the problem. As I told you over and over again, not all the time standard equations and formulas will be logical always. How to solve the problem. There are a lot of problems that requires critical thinking analysis before you proceed. And the example to this is to use the dimensional analysis conversion way of solving. Dimension meaning there's measurable physical property, for example, volume, mass, weight, like that. So these are measurable, quantifiable, or a physical property, something like that. Or basically, exclusively, the extrinsic property of the phases of matter. Okay? Get the point. So we will review also the properties of matter in this case, right? So assuming we have now the stock knowledge of the theory, so we proceed here. Okay, now propane. You can see the items in the whiteboard na mga palangga. So propane, C3H8 plus oxygen gas. This is a combustion reaction, a chemical reaction. It's not specified, but is obviously a combustion. So CO2 plus water. Oh, ganon. So this is our unbalanced chemical reaction. So we need to balance that before proceeding further. Things like this, guys, is a requirement in dimensional analysis conversion way of solving the problem. Okay? Like that. So we need to balance and we go directly to the trial and error method of balancing because it requires time if we will be able to do the algebraic way of balancing the chemical equation, obeying the law of conservation of mass. Okay? But here we need to go directly the trial and error method. There's no problem. Why? Because there's lesser subscript. The highest subscript is only 8. So we can expect that there's no fraction chuba chuchu will be there during the balancing of the equations. But if there are a lot of fractions somewhere along the way in your balancing of the equation, and you cannot use anymore the trial and error method. Mga multi kasi assume from 1, 2, 3, 4, 5, 6, 7, 8. Better use the proper way of how to balance the chemical reactions. Again, the proper way of balancing the equation is not trial and error method. Okay? That is only good for lesser number of atoms, lesser number of moles. And the subscript are very few or small, like this. But if it has a lot of atoms like that, then it's expected that it will involve fraction, use the algebra. Okay? Algebraic expression. Meaning, the total number of atoms in the reactant will always be equal to the number of atoms of the product. Then let X as the number of atoms to be solved. Okay, let X the ganon siya. So you can solve for the number of atoms. But in here, let's just use the trial and error method because it's easy man siya to visualize. Okay, or to, to put something chuba chuchu. Okay, here. So, carbon 3. I have to put 3 beside the carbon. Okay? Then we have hydrogen 8. Put 4. Okay, beside here. Okay, so hydrogen 8 na. Hydrogen 8. Now, oxygen. 6 plus 4, 10. And you have 2 here, so times 5. This is through visual inspection, trial and error method, balancing of equation. Now, this is completely balanced or not? Then review. Scrutinize one by one. Carbon atoms, left 3, right 3. Hydrogen, 8 left, 8 also in the right. And oxygen in the left is 10, and also the total oxygen atoms in the product is going to be 6 plus 4 is equal to 10. Perfect. This is balanced already. Okay, now the question goes like this. What volume of CO2 will be produced? Okay, we need to say it's the volume of the product CO2 is being asked. Question mark. Ganon. If 8.4 liters of O2 reacts with excess propane gas. So this will be our basis of calculation. Okay, 8.4 liters of oxygen gas. Okay? At least one basis of calculation in this manner in solving the problem. 8.4 liters of oxygen gas. Ganon. This will be used. Okay. Now, what volume of CO2? In this case, you will tend to use the Boyle's-law. You know why? Because there's volume, okay, like that. I'm sorry, you need to use the Avogadro law because there's a volume and there's also number of moles in the stoichiometric relation. Shit, something like that, okay? But in this case, things like this, guys, you need to assume that this is also an ideal, something like that. Because usually, guys, a perfect complete combustion will assume to be in an ideal state. You get the point? Complete combustion. We have also incomplete combustion. But in this case, even though it's not mentioned that this is an ideal or not, because there's no word ideal, and there's also no word is TP. Sometimes students will be dependent on the term ideal and the term is TP. Kung wala din na siya, hindi niya i-assume. You get the point? Of course, unless otherwise specified. But we have the theory. If complete combustion in all hydrocarbon in the atmosphere, then it will behave as an ideal gas. You get the point? Unless given the parameters or the operating conditions, the temperature, the pressure, the volume, so it could not be an ideal anymore because there's a given. Okay, it will just hold through that concept if not specified other operating parameters. In this case, there's no temperature, there's no pressure, right? So you cannot say that this is not an ideal. This is really an ideal, okay? Because of that, and in fact, this is a complete combustion. Okay. So, Sotero, how can we identify that it is a complete combustion? It always yields a product of carbon dioxide and water, right? Because if it is incomplete, there is carbon monoxide. Okay, there's carbon monoxide and there's also carbon atom. So it will become carbon monoxide plus carbon atom plus carbon dioxide plus water. There are four products in incomplete combustion in adding oxygen gas plus any hydrocarbon. Meaning any hydrocarbon, it could be methane, propane, butane. So a lot of, alkyl group. We call them as an alkyl group. Okay? Starting from methane until dodecane or decane. So let's say dodecane, 12 carbon atoms is the last. And you have to pattern that there. Okay? In chronological order. Meaning to say in ascending order. Okay, ascending, increasing atomic number, starting from the natural gas methane to the dodecane. Katong 12 carbon atoms. You get a point? Something like that. Okay, you should be extra careful with this combustion type of problem. Okay, our theory will work for this. Okay, like that. It's not really that formulas. Okay, 8.4 liters. Oh, actually, guys, it looks like also difficult. Okay, me also personally to look at this. Okay, now since complete combustion, we need to use the relationship of a temperature equal to 0 degrees Celsius. Pressure is equal to 1 atmosphere. And for every 1 mole of an ideal carbon dioxide, because carbon dioxide is mentioned here, it will occupy 22.414 liters of a gas. Okay, why? Because we are assuming that it behaves ideally at STP for the reason that it is a complete combustion. Nagbalik-balik na lang ko guys. Okay? If it is a complete combustion, assumed to be this way. But if they're given temperature and pressure, ayaw pugsa. It's not really that an ideal, something like that. Okay? You get the point? Now, we have the proper solution for this. Okay, ganon. Basis of calculation, and I'll show you two options, guys, how to solve this one. The other one is makalibog, and the other one is easy to manage. Okay? Makalibog, guys, meaning confusion in English. Bisaya is makalibog. English is confusion. And then in Tagalog, nakakalito. Okay? So there are three languages used now, in the interpretation of language. Oh my gosh, I hate drugs. Okay, 8.4 liters. Okay, 8.4 liters of oxygen gas. Now, this is an ideal gas for every 22.4 liters gas. Okay, we have 1 mole of oxygen gas because you are referring to oxygen now. You get the point? It's not yet the carbon dioxide. You are still in the reactant or in the raw material side, adding a combination of oxygen and propane. Now, step number 2, you'll take a look in a stoichiometric balanced equation. Now, you have the mole of oxygen, guys. Be sure that this mole also will be in the denominator. Okay, mole. But this time, it's the CO2 already because you need to find out the CO2 properties or the volume. Okay, so mole of CO2, and then we try to look at that stoichiometric relationship. Okay, how many moles of oxygen gas? 5. Again, 5 moles of oxygen gas. So that you will cancel this mole of oxygen gas. Pareho siya. Okay? And then the CO2 will appear. Bilis mo yung hindi panita. Okay? CO2, 3 moles of carbon dioxide. Ganon. Okay? Now, you will stop here or not yet? You will not stop here because this is still mole, not a volume. Okay, again, going back to ideality. Okay, 1 mole of carbon dioxide, okay, it will now occupy 22.4 liters. So tell you why always using 22.4 liters? Because all of them are behaving as an ideal. The propane gas, the oxygen gas, the CO2 gas, and the H2O vapor. Okay? Like that. You get the point? So, if you assume that's an ideal, all of them will behave as an ideal. So that's why. So, 22.414 liter of CO2 siya. Now, cancellation, compatibility of the data, given unit, and variable. Okay. We have to cancel this oxygen liters. Cancel mole of oxygen, mole of CO2 cancel also. What will be left is the liter of carbon dioxide, which is being asked in the problem. So, what volume of CO2? So you get that there already. Now take note the parallelism theory. What do you mean parallelism? Meaning there's the same numerical figure, the at the same time unit. Okay, so we have 22.414 liter at the top, and we have also 22.414 liter at the bottom or in the denominator. So we have to consider immediately the 22.414 liter. We need to put that in the calculator by theory alone. So what we left here? So the liters of carbon dioxide. Ganon. Okay, so liters of carbon dioxide. Ganon. So, let's simplify further. Okay, 8.4 times 3 divided by 5. Okay, calculator please. I cannot solve this by my brain cells. Okay, 8.4. Okay, mga palangga times 3 is equals to divided by 5. Okay, the answer is 5.04 liters of carbon dioxide. Okay, this will be the answer. Okay, 5.04 liters of carbon dioxide. This will be the answer for option 1 or method 1. For the method 2, it looks like it needs to be more on critical thinking based on the theory. Something like that. Since this is an ideal gas, you treat this, and then you will apply immediately the concept of the ideal gas equation. Now, PV is equals to nRT. Okay? Like that. PV is equals to nRT. Now, you are looking for the volume. And N is the number of moles. Okay? And then pressure is standard, temperature is standard, then of course the R is also standard, universal gas constant. Okay, so what we'll be trying to include in the relationship is the volume and the number of moles, something like that. You get the point? Okay. Then, if the volume will increase, the number of moles will also increase. It's directly proportional with each other, right? You get the point? If the volume will increase, the number of moles will also increase. You get the point? So, what will be the situation now in this case? Okay? So, we have to relate that here. Okay? So, we can solve that in this situation. Okay, so 5.74 liters of CO2, ganon, okay. Now, we have also to include that oxygen here. Okay, that's the point. Because that is a liter. Okay, liter of CO2. 1 liter of CO2. Ganon. Okay, so we have now 22.414 liter of CO2. Ganon. You got the point. And then, for the oxygen, we have also 22.414 liter of oxygen. Ganon. So, muna siyang other method. Atong papason, kinisamok siya. Okay? So, basta ang ato answer sa ano, guys, 504. We are on the second method, guys, ha, mga talangga. Okay. If the volume will increase, the number of moles also increase. So, meaning to say, even though we will not use the number of moles relationship, we can use directly the volume. You get the point? Ganon. Okay. 8.4 liters of oxygen gas. Nakakaluka, di ba? And then, pila man ang relationship ani sa oxygen to CO2. Okay, dire ka na ba? Di ba? So, 5 moles of oxygen gas and 3 moles of CO2. O ganon. So, meaning to say, the number of moles is equals to the volume. You get the point? Because they are directly related with each other. If the number of moles will increase, the volume also will increase. Now take note, this number of moles in the chemical reaction is not the number of volume. But by theory, this volume and number of moles will just behave at the same manner. That's why if you increase the volume, the number of moles will increase. The same also using that directly in our dilutional analysis. So I could say that 5 moles of oxygen gas, we also have 5 liters of oxygen gas. If I have 3 moles of carbon dioxide, I have also 3 liters of carbon dioxide. Because of this concept that the number of moles and the volumes in this kind of problem is directly proportional with each other. Number of moles increase, volume moles increase. So we can equate that immediately. Okay, so 8.4 liter of O2, and now we have 5 liters of oxygen gas. Okay, in the denominator. And then CO2 volume is being added. Okay, so 3 liters of CO2. It looks like strange, right? Strange, meaning to say unique. Because you need theory to prove this. Okay, because this 3 liters is not really the liters, it is moles in the chemical reaction. But through theory, the number of moles and volume is just equal. Something like that. It will be directly proportional to each other. It will behave in the same thing. Something like that. That's why 3 liters is also equal to 3 moles, and 5 liters is equal to 5 moles. And then we should be extra careful also. This will hold only in ideality, in this kind of situation. But if not an ideal, do not assume the number of moles all the time with the volume. Okay, check the condition. Okay, like that. In this case, pwede siya. Okay, letter cancel, what will be left is 8.4 times 3 times 5 is still equal to 5.04 liter of CO2. Actually, when you solve this problem, it's very easy because directly, but it's very, it's very confusing because of the theory thing. Okay, but go to the other one now because it is more proper. For me, that will be the more proper because I'm not really good in IQ regarding math. I can be easily confused. Okay, to those who already have a high math IQ, they better go to this directly. Okay, but actually you can use that directly. Okay, if you're really taas ang mong IQ, but for me, I'm not. That's why I use the proper way. You get the point? Okay, it depends on your strength. Okay, how to solve conveniently and comfortably. Who dares to think energetically that the volume and the number are equal, right? So you cannot think that on the spot also, examination, and you still remember the theory. How can it be? We are relying to the standard equations and formulas most of the time. Okay, so purely academic. Okay, who wants to keep on thinking and thinking? So it will cause a headache to your brain cells. So we would rely to the most easy to remember, right? Things like that by common sense. But if you have already a high intelligence quotient, then you can do that. No problem. But for me, I will try to use the option 1. Okay, any questions so far for this type of question? Actually, this is really difficult to consider because, in the future examination, it will be rumbled. You know, rumbled, mixed. So who dares to think situation like this? Okay, so meaning to say, you can be focusing on the more difficult, yeah, things like this. It looks like easy, then you will take for granted. You get the point? That's why it's the main reason that a lot will fail also because of that reason. Because they focus more on the difficult problems. They solve a lot of problems, really a lot tool, focusing on the most difficult because they will say, that's very easy to solve, no need to solve that again, I know that already. So it's not like that actually. You will focus to all the time to the basic problems. Easy to understand. Okay? Because it's not difficult all the time that will come out in the examination, especially problem solving. It's not like that. Okay? That's only our mentality. It's gonna be 30% to 40% only problem solving. And the rest will be theories, concepts, principles, like that. Okay? So kung mamundo ka sa theories and principles, then bingo. You have 80% up to pass the examination. You get the point? Because it's impossible also all problems you cannot solve it. Okay? By normal circumstance, it will start with the simple, average, a little above average, and then difficult. It's impossible also that they will give all difficult. Sure, nobody will pass. Okay? So, that's it. See, I give kumpiyansa sa theories, principles, concepts, and basic foundation how to solve the problem. And I just focus with me sa lisod. That's my advice. Okay? Right? Don't focus always on the difficult problem solving. Okay? Focus on the basic foundation that is easy to average or above little average problem solving. Okay? So that's it. Thank you so much. If you can comment, like, and share this vlog of mine, then you can do it. And you can subscribe my YT channel if you are not yet subscribing my YT channel. And you can also click the notification bell for some news updates regarding the singer, eternal voice. Bye bye, God bless everybody. See you later for my another vlog. Wow. Bebe and Sarah.